This lesson is solving quadratic equations. It's a review. It's something easy to forget. It's something we need to be sharp on and practice on. So we're going to overview it and practice solving a quadratic. Now, a quadratic means the greatest exponent is 2. It's in the family of polynomials. We're going to go through each one right now. So here's an equation, x squared plus 6x plus 5 equals 0. There's going to be 5 different ways we're going to solve it. Isn't that exciting? And each one is essential in itself, and usually there's the best method. Sometimes the best method isn't always the easiest or quickest way, but each method you can't ignore. We need to understand each one and practice each one. All right, so the first step is to graph. If I'm going to graph this, I need to know the vertex and the intercepts. And so to find the vertex, formula is negative b over 2a to find the x value of the vertex. So in this situation, a is 1, b is 6, c is 5. So negative b, and then so plug in the values of b and a. So the vertex is at negative 3. To find the y value, you take that answer and plug it back into the equation. That gives you the answer of negative 4. So we have an equation here at negative 3 and negative 4. My eyesight's going to go here. So there, at negative 3, negative 4. And then it folds up from there. To find the intercepts, we would factor it, which we're going to do down here anyway, so might as well do it now. And so we need to know two numbers that multiply to 5 and add to 6. So the two numbers that multiply to 5 and the same numbers add to 6 are 5 and 1. Those are your factors. Your solutions are the zeros of that. So that would be negative 5 and negative 1. And we'll draw it from there. And here becomes the important part of this, is how do you solve something off a graph? If I'm solving a quadratic equation, the x-intercepts are my solutions, just so you know. So this is my answer right here. To use graphing to solve an equation would be the least likely, but to know how to interpret a graph to solve it is essential. So it's essential that you know that the x-intercepts are the answers you're looking for. Factoring, we just factored this. So if we factored it, each factor has a 0. So that's negative 5 and negative 1. That's what makes it 0. It's called the zero product property. Square roots. So this can't be done here. And why can it not be done? So a quadratic may or may not have a linear term. So a linear term is a term with the exponent 1 on it. So if I look here, x squared is called the quadratic term. 6x is the linear term because it has a 1, and then 5 is the constant. If there was no linear term, if it was just x squared plus 5, then you could solve using square roots. Complete the square. This is an essential skill again. So could you solve this by completing the square? So the key is this formula. To complete the square, you take the b value divided by 2 and square it. That's the key. So on the side, the b value is 6. I'm going to divide by 2 and square. So that's 3 squared. And that number, I'm both going to add. I'm going to add 9. I'm going to put parentheses around it. I'm also going to subtract it because 9 subtract 9 is 0, so it stays the same. And then we still have a plus 5 there as well. So we found a number to both add. That allows me to factor. And subtract. That means it stays the same. And now I'm going to solve it. So this is now factorable. So what number times itself is equal to 9, and they add up to 6. So the two numbers to factor it are 3 and 3. And because they're the same, this is a perfect square. We could write it as 1 factor squared. Negative 9 plus 5 is negative 4. And now we're going to solve this. So we're going to add 4 to the other side. We're going to square root. Whenever you solve a quadratic, the answer could be positive or negative. So the square root of 4 is 2. That could be positive or negative. And then we have two equations to solve here. One for positive 2 and the other equation for negative 2. You solve each one separately and you have your two answers. So subtract 3, and 2 subtract 3 is negative 1. Subtract 3, negative 2 subtract 3, and you get your two answers. The last method here to solve a quadratic is to use the quadratic formula. So if I write that down here, ax squared plus bx plus c, if that equals 0, there's a formula we could use at any time to solve it. And so that formula is negative b plus or minus the square root of b squared, subtract 4ac all over 2a. So with practice, you remember it. So we're going to use this formula for that equation. So again, the equation was x squared plus 6x plus 5 equals 0. A is 1, b is 6, c is 5. We're going to use these values in this formula. So again, the formula is negative b plus or minus the square root of b squared. So 6 squared is 36. Subtract 4 times a times c all over 2a. So 2 times 1. And now I'm going to simplify that. So you have negative 6 plus or minus the square root of 36, subtract 20. 2 times 1 is 2. Just keep working at this equation until you've solved it. 36 take away 20 is 16. The square root of 16 is 4, and here are your two answers. So 2 goes into both evenly, so we could really write this as 6 divided by 2 is 3, and 4 divided by 2 is 2. So negative 3 plus 2, negative 3 subtract 2, and you have your two answers. So notice you're getting negative 1, negative 5 each time. Quadratic formula, completing the squares. We'll do examples of what it means to solve using square roots soon. Factoring, and we actually did the work for factoring up here. I just repeated it down here. And when you look off a graph, we're looking for the x-intercepts. That gives us a solution. Turn the page with me. So another important part of solving a quadratic equation is understanding the discriminant. So if ax squared plus bx plus c, if you have this equation, the discriminant is b squared minus 4ac. And you'd recognize it because it's underneath the square root sign of the quadratic formula. So the discriminant is b squared minus 4ac if we have this equation. And our discriminant tells us if the answer is real or complex, if it's rational or irrational. So we're going to go through that right now. So if I evaluate this and the answer is positive and a perfect square, then we have two roots, and a root is another word for solution. So if you see the word root, that means solution. We can also say that means x-intercepts too. They all mean the same thing. Or zeros. So those are like 4 words you could see. Root, solution, x-intercepts, zeros. They mean the same thing. All right. So the number of solutions is 2, and they both are rational. If the discriminant is positive, not a perfect square. Now, perfect square means you can take the square root of that number, like 4 and 9 and 16. So if it's not a perfect square, but it's still positive, there's still 2 solutions. But both solutions then would be irrational. I just realized these are capitals, these are not. That's not good form. I should stick to one type. All right. What happens if the discriminant is equal to 0? That means there's one root, and that one answer is rational. What happens if this is negative? You have two answers, but if you take the square root of a negative, now the solution is complex and requires I, the symbol for the square root of -1. It's now become that imaginary answer. So let's practice this. So we're going to practice finding the discriminant and then determining the number and types of solutions it comes up with. So we're actually not going to solve it. We're just going through this process. So I need to recognize that A is 2, that B is 12, that C is -13. The discriminant is B squared minus 4AC. At this point, it's okay to use a calculator if you want. I'll do it for you. It's 248. And 248 is not a perfect square, but it is positive. So therefore, we have two irrational roots. They're real, but they are irrational because you cannot take the square root of 248. We're going to do that work again. So A is -1, B is 16, C is -64. I want to find the discriminant. So that's B squared minus 4AC. And then you're going to calculate that. If you did this work, the answer is 0. And then you can look up here. If the discriminant is 0, there's one root and it's rational. Number 3, it's not equal to 0. That is essential. I've said that word a couple times already. Subtract 10x plus 84. So we're going to subtract 10x. It must be equal to 0. Then you can write down what A equals, what B equals, and what C equals. And then you use the formula B squared minus 4AC. So again, it's okay if you used a calculator. I'll calculate it for you. It's 1,444. If you took a calculator and square root, it actually does have a square root. This is a perfect square. 38 times 38 is this number. I don't expect you would know that by memory. And because of that, it's a perfect square. There are two rational roots. Here's the situation. If I was solving it, this would be a situation to use square roots to solve it. There's no linear term, so you would isolate the x squared and square root to get the answer. All right, so it is equal to 0. A is 3. B you don't see, right? There's no linear term, so it's 0. And C is 24. So the formula is B squared minus 4AC. So that answer is -288. Because the discriminant is negative, because it's negative, we have two complex roots. So we have 5 methods to solve a quadratic. And then a good question is, when should you use each one then, right? So we have a graphing method. Honestly, the equation should likely be in a form where it's easy to graph. So this is called vertex form or HK form, where the vertex is HK and it'd be easier to factor. You can use graphing anytime to solve, right? So at any time you can graph. If the parabola does not cross the x-axis, that means the solutions are complex. But then to find the complex, you'd have to use the quadratic formula. Factoring. So again, it would be in this form. And it would have to be factorable. Not all quadratics are factorable. Square roots, it would be in this form. And no linear term, that's what we're looking for. Completing the square, I want you to notice that A has to be +1. That's why I didn't put an A there. So, and it doesn't have to be, but really B should be an even number, or else it creates fractions and it creates a lot more work. So if A is 1 and B is an even number, that's when I would choose to complete the square. And if it's not factorable. If it's factorable, this is where you go to right away first. This is number 1 right here. to solve a quadratic, is it factorable? When it's not factorable, then these other methods come into play. And you know the quadratic formula. The more times you write it down, the more likely you're going to remember it. And again, you can use this anytime, but again, this is like the last resort. So the last one I think about is the quadratic formula. If it's not factorable, if A is not 1 and B is not an even number, at the very end, then that's what I go to solve it. All right, so the next page we have 4 equations, and we're going to think through how we're going to solve it. And we have 4 different methods to pick from, and you can only use one method each time. So we're going to try that. So first of all, we're going to find the discriminant and see how that can help us. So the discriminant is b squared minus 4ac. So if I solve that, I get the answer -3. If I have a negative discriminant, let's see if it gets back into focus. There it is. If you have a negative discriminant, we need to either solve with square roots. I have a linear term. I need to use the quadratic formula. I know then it's not factorable, and I know that I either have to use square roots, but I have a linear term. So, and I could also, I guess I should back up just for a second. You could also complete the square, but b is an odd number. So the best situation for this, it's complex. B is an odd number. I would use the quadratic formula. So we're going to go down to the quadratic formula. And we already solved the discriminant part. So here we are down here. So this is going to be equation A. And so the equation was, again, x squared minus 9x plus 21 equals 0. So the quadratic formula is -b plus or minus. Now we already did b squared minus 4ac. We said that answer is -3. So I'm not going to redo that work. And then the denominator is 2 times a. So that's 2 times 1. And then I'm going to simplify it. So a negative times a negative is +9. The square root of -3, well, the square root of a negative number is imaginary, and the square root of 3 is irrational, so it's going to stay there. And then 2 times 1 is 2, and you have your solution. So recognize the square root of a negative number is going to require this symbol here, I, which represents imaginary. All right, equation number B. I notice this has no linear term. So b squared minus 4ac, and then I'm going to calculate it. And if you do that, it's 1,152. So, I should write this down. There are 2 complex roots here. Because the answer is positive, but you cannot take the square root of 1,152, this is 2 irrational roots. So we're going to use square roots because we have no linear term. So we have -2x squared plus 144 equals 0. We're going to solve this. So I'm actually going to add 2x squared, and I'm going to divide both sides by 2. Half of 144, 72. Sure, I can do that. And then the last step is to square root. That's why it's called a square root method. Square root. The answer is positive or negative. 72 is not a perfect square. So bigger number, 36. 36 goes into it evenly. That allows us to reduce it down. 9 times 8 is good, but then you have to continue to simplify after that. So 36 is better. So the answer is plus or minus the square root of 36, which is 6, and then the square root of 2 is left over, and we have the 2 solutions. All right, we have 2 left. Equation C, b squared minus 4ac. So I'm going to solve that, and I get the answer 400. That's the discriminant. I can take the square root of 400. So because of that, it is factorable. If you can take the square root of the discriminant, that means it's a perfect square. That means it's factorable. So I'm going to go right to factoring right now. There are 2 rational roots, and I'm going to factor it. So let's factor it together. So we have 3x squared subtract 22x plus 7. Step 1, I'm going to go 3 times 7 and then negative 22 is going to go underneath. We're going to organize this, and I need to find two numbers that multiply to 21, and the same two numbers add to negative 22. So I'm going to put those two numbers down. So once I find those two numbers that fit, then I go back to the equation. I'm going to replace negative 22 with negative 1x and negative 21x. So I do a substitution, and now I'm going to factor by grouping them together. So I look at the first two terms. They have an x in common, so I factor out an x. I look at the next two terms, a 3, but I'm going to factor out a negative 3 that goes into both evenly. That way, what's left over can match. So when you go negative divided by negative, oops, I didn't mean 3, I meant 7. So factor out a negative 7. Negative 21 divided by negative 7 is 3. 7 divided by negative 7 is negative 1. It's essential, again I use that word, that these match. So they have a common factor of 3x subtract 1, and what's left over is x subtract 7. You have now factored this. Each factor equal to 0 and solve. For the first one, we're going to add 1 and divide by 3. And for the second one, we add 7. We have two rational answers that we solve by factoring. All right, we got one left. So we're going to complete the square. So b squared minus 4ac to begin with. So this is 36 plus 60, which is equal to 96. 96 is not a perfect square. So we have two irrational roots. So we're going to solve this. Notice a is 1 and b is an even number. So we're going to complete the square here. So x squared plus 6x subtract 15 equals 0. To complete the square, we need to know this little formula here to complete the square, which is take b divided by 2 and square it. So b divided by 2 and square. This is I need to remember. My b value is 6. Divide by 2 and square it. So 6 divided by 2 is 3. 3 squared is 9. So I come back to the equation. I'm going to add 9. I put parentheses around it to kind of separate it. I'm also going to subtract 9 as well, so it stays the same equation. We also have subtracting 15. This is factorable. So the two numbers that multiply to 9 and add to 6, we set it up this way. It's the same number. 3 times 3 was what works. Negative 9, subtract 15 is negative 24. So now we're going to solve this. We're going to add 24 to the other side. We're going to square root. When we solve a quadratic, the answer could be positive or negative. How do I simplify the square root of 24? That's 4 times 6. So the square root of 4 is 2, and what's left over is 6. And then the last step to get x by itself is to subtract 3. And you have your answer. All right, turn the page. We're almost there. So now we're going to practice, and you get to pick. Well, first we're going to practice each one, and then you're going to get to pick which one, and we're going to practice together. So if you need to, press pause to take a little break, and then we're going to do this. Here we go. So the first thing is it must be equal to 0. What's the first thing? It must be equal to 0. Subtract 6x, so now it's equal to 0. Is this factorable? Well, it says factoring, so I hope it's factorable. So what two numbers multiply to negative 7, add to negative 6? So find the two numbers that fit. So one factor is negative 7, the other factor is x plus 1. Each factor is a solution. So the first factor, the 0 is 7. The second one, the 0 is negative 1, and you have your two answers. For number 2, it is equal to 0. So right away, I'm going to go 4 times 24, which is 96. And then 35 goes underneath. I need two numbers that multiply to 96, and the same two numbers add to 35. So the two numbers that fit are 32 and 3. They multiply to 96. They add to 35. Come back here, do a substitution. So substitute out 35 and put in 32 and 30 and 3. We're going to factor out a common factor, so it would be 4x. That leaves me with x plus 8. Factor out a 3. That leaves me with x plus 8. Notice how these match. They have to in order to work. So they have a common factor, and what's left over is 4x plus 3. Take each factor and you have a solution. So x plus 8, the 0 is negative 8. 4x plus 3, we're going to subtract 3 and divide by 4, and you have the solution. So that's solving by factoring. That is number one. If you can do it, that's the way you're going to do it. Number 3, square roots. So it needs to be, well, for a square root, it does not need to be equal to 0, but we cannot have a linear term. So we don't have a linear term here. 10x squared is a quadratic. We're going to subtract 2, and we're going to isolate the x squared. So we're going to divide by 10, and then when we square root, the answer could be positive or negative, and 28 can be written as 4 times 7. So the square root of 4, and then what's left over. Number 4, again, no linear term. So I'm going to subtract 50. That's negative 216. I'm going to divide by 2. That's negative 108. So when I take the square root here, the answer is positive or negative, and it's going to be imaginary because the square root of a negative number is imaginary. So 108 is not a perfect square. The perfect square that goes into it evenly is 36. So I'm going to write negative 36 times 3. The square root of negative 36 is 6i. And then what's left over is root 3. So that's square roots as a method. The next one is completing the square. So again, it's essential that a is 1, in that it's really important if b is an even number to make it easier. So the first step is b is 12. So I'm going to divide it by 2. So it's b divided by 2 and square. So 6 squared is 36. So I'm going to come to the equation. I'm going to add 36. I'm also going to subtract 36. And everything else is the same. So it's the same equation, but now I've set it up to complete the square. So what's inside the parentheses is factorable. Two numbers that multiply to 36, the same two numbers add to 12. So that's 6 and 6. Then I'm going to combine like terms. So negative 36 plus 3. And then I'm going to add 33 to the right side. So 7 plus 33. And then I'm going to take the square root to both sides. So again, the answer could be positive or negative. 40 is not a perfect square, but I can simplify it. 4 times 10. So the square root of 4, and then what's left over is root 10. The last step to get x by itself is to subtract 6. And then you have your solution. That's called completing the square. We're going to do it again for number 6. I want to complete the square here. So it's negative 12 divided by 2 and square it. That's negative 6 squared. Again. Oh, and I can even do, let's scratch this out for a second. So is a equal to 1 here? No. So actually the first step here, to make it easier, I'm actually going to combine like terms. I'm going to add 38 to the other side. So 10 and 38 is 48. And then I'm going to divide everything by 6. It's not ready to complete the square until a is positive 1. So 6 divided by 6, it's now 1. Negative 12 divided by 6 and 48 divided by 6. Now we're ready to do the work I wanted to do, because a needs to be positive 1 in order to do the work we're doing. B is negative 2. Divide by 2 and square. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So we're going to add it. We're going to subtract it. And now we're going to do the work. So this is factorable. So it's negative 1 and negative 1. So two numbers that multiply to 1 and add to negative 2. Negative 1 and negative 1. We're going to add 1 to the other side. And then we're going to square root. So this is x subtract 1 is equal to plus or minus 3. and then add 1 to the other side. And so now the two solutions, 3 plus 1 or negative 3 plus 1. So one answer is 4 and the other answer is negative 2. Number 7, we're going to practice using the quadratic formula. So it must be equal to 0. It is. A is 5, B is 4, C is 1. See if it focuses in. So the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to simplify it. So one step at a time and get it simpler. So negative 4 times 5 times 1 is negative 20. 2 times 5 is 10. 16 take away 20 is negative 4. Now, the square root of a negative number is imaginary. So this is plus or minus 2i. So the square root of 4 is 2. And the square root of a negative number is I. That's why it's 2i. And then divide 2 by everything. Or 4 over 10. I'll do that here. 4 over 10 is negative 2 over 5 plus or minus 2 goes into 10 5 times, so it's just I over 5. In number 8, we need to make it equal to 0. You need to write down what A, B, and C equal. And then use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we're going to simplify it. So a negative times a negative times a negative is a negative answer. So this is negative 40. Four take away 40 is negative 36. The square root of a negative number is imaginary. So the square root of 36 is 6, but it's going to be 6i because it's negative. And then reduce it down. So negative 2 divided by negative 4 is 1/2, and 6 divided by 4 is 3/2, both positive and negative, and an I. Now, the last 4, you get to pick. Which is the best method? So in number 9, the first thing you think is it needs to be equal to 0. I can't pick the square root method because we have a linear term. Is it factorable? Well, if I go b squared minus 4ac, this will tell me if it's factorable or not. It's one of the ways. So 9 plus 80 is 89. You cannot take the square root of 89. This is not factorable. So a is not 1, b is not an even number. This is going to be the quadratic formula. So negative b plus or minus. Now we already did b squared minus 4ac. So we know that answer is 89. I don't need to do it again. And then 2a in the denominator. So we have 3 plus or minus the square root of 89 over 4. There's no way to reduce down 89, so there's your answer. Number 10. I want to make it equal to 0. So we use the quadratic formula, just so you know, for this one. To make it equal to 0, we're going to subtract 2x. So when I subtract 2x, 10 take away 2 is 8. That is a linear term, so we can't use the square root method, so we're going to factor. So we're going to factor out an x. It's not a trinomial, so I don't need a diamond. X by itself, the answer is 0. X plus 8, the answer is negative 8, and I have the two answers, and I factored there. Number 11, I have no linear term. So I'm going to add 39. I'm going to divide by 4. So my whole work is to isolate the x. When I square root a fraction, I know the answer is positive or negative. Just square root each one separately. No biggie. The square root of 49, the square root of 4, and you have your answer. So we use the square root method here. For the last one, for this lesson, we need to make it equal to 0. Now, I notice that a is negative 1, but I can easily make it positive 1. So I can add x squared, subtract 2x, and it's already positive 7. It is not factorable, but a is 1, b is an even number. This is set up to complete the square. So b is negative 2. I'm going to divide by 2 and square it. That gives me the answer 1. So I'm going to come back to the equation. I'm going to add 1. I'm also going to subtract 1. And then I'm going to simplify it. So these parentheses is factorable. So the number that multiplies to 1 and adds to negative 2 is negative 1 and negative 1. So I factor this as negative 1 squared because it's the same factor. Negative 1 plus 7 is 6. And now I'm going to solve this. So I'm going to subtract 6. Whenever you take the square root of a negative number, the answer is imaginary. The square root of 6 is prime. I can't reduce it down. It's irrational. And then the last step to get x by itself is to add 1 to the other side. Oh, and make sure the answer is positive and negative. So our final answer is positive 1, positive and negative I root 6. Two complex solutions by completing the square. All right, you did it. What a great review on solving quadratics. Thank you for doing your work. And until next time, Mr. G Math, over and out.